Right, everyone, we have question number 3 here, and we're essentially, let's see here. So we're given a random variable x, and that's the number of ATMs that are working when the mall opens. And so we're definitely going to be using this type of equation going on here, or this type of, formula. This is a discrete random variable. So with that being said, let's dive in. So part A is, what is the probability at least one ATM is working when the mall opens? So this is a popular probability concept, and since we're talking about the number of ATMs, that's also the random variable x, so we can say this is the probability that x is greater than or equal to 1. In other words, at least one or more of x, the number of ATMs, are working. Now that's equal to 1 minus the probability of none, because if you don't have one or more, you have none working. All right, and so the opposite of, or the complement of, is the real stat word of the condition you want is 1 minus the opposite of that. So if 1 or more is opposite to 0, then we'll find 1 minus the opposite of 0, and we'll get the answer we want. And this is 1 minus 0.15, and that just equals 0.85. So, I mean, also, could you just simply add the 0.21, the 0.4, and the 0.24 and get the same answer? Yes, but you'll probably see it like this. Plus, this is just one subtraction rather than 3 additions, so whatever way you see it fastest, but to me this is the fastest. Okay, part B, the expected value of ATMs. So that's where I'm going to look at my reference sheet, and that's called e to the x. So I'm going to say, or not e to the x, but ex, sometimes called the expectation of x, and that is simply each value times its associated probability. So 0 and the 0.15 multiplied together, plus the 1 times its probability, which is 0.21, plus 2 times 0.4, plus 3 times 0.24. And unfortunately, I need a calculator now. So the first term, the 0 times whatever, is just going to be gone. The 1 times 0.21 is just 0.21. Now we have to do some math. Plus 2 times 0.4, plus 3 times 0.24. Looks like I get 1.73. And I'm going to make sure that I did this correctly. So 0.21 plus 2 times 0.4, yep, plus 3 times 0.24. Okay, awesome. Now remember, I mean, this doesn't make sense. You obviously can't have 1.73 ATMs working, and the ATM is either working or it's not, but expectation can be this weird decimal form. Okay. Part C. What is the probability all 3 ATMs are working when the mall opens, given at least one ATM is open? So I'm going to write that like this. It's the probability of all given, I guess I'll say it like this, x greater than 1. All right. In other words, the given is what we did in part A. Now, remember your probability formula. It's the probability of all and x being greater than or equal to 1. This is kind of a weird way of writing it, but it is technically true, divided by the probability of the given. All right, so it's always and divided by the second, and that's their probabilities. Now, the thing is, what is the probability that it's all and x is greater than or equal to 3? Well, all and x being greater than or equal to, 1 is the same as just the probability of x being 3. That's all. And when x is greater than or equal to 1, that's where they overlap when it's exactly 3. And we already calculated this before in the last example. This is, or in part A, this is 0.85. And so we have, well, it's probability 3 are working, this. So now let's just divide those two things. And we'll round that to 3 or 4 places. 2, 8, 2, 4. Awesome. So now we just have one more question. So I honestly don't think this one's been too bad. This has been my favorite so far. But I know probability can be gross, but I'm just so glad all the crazy wording is gone, and to me the crazy wording is gone. But anyways, okay, back to it. Given at least one ATM is working when the mall opens, so again, that's this part again. Would the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value from part B? Okay, so not gonna lie, on part D, I did end up checking the scoring guideline because I wanted to be sure about what I was going to do. I was on the right track, but I was a little shaky about what was going on in the problem. But here we go. So, part D says, given at least one ATM is working, would the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value of part B? Now, here's the best way to, I think, arrive at the answer. If you notice, in part C, you've done part of the work to answering the question. So in other words, what's going on here is when it says given at least one ATM is working when the mall opens, well, that means this answer choice is, or this is eliminated. Now, when that happens, that means these three are the only possible values. And remember that in probability, all probabilities have to add to 1. So in other words, imagine this is blacked out. Imagine you only have these three options. Well, these don't add up to 100%. And in probability, everything has to add up to 100%. So somehow this 15% is getting distributed to the parts that are left over. And so that means it's actually going to increase, but here's, or it's going to be greater than the expected value from part B, but here's what I'm going to do. I'm going to say probability of x equals 2, given that x is greater than or equal to 1. That's equal to, and I'm going to skip the work here because you can see that I've actually pretty much laid out all the work from before. Okay, and let's see, the probability that x is 1, given that x is greater than or equal to 1. Well, again, it's going to be 0.21 divided by 0.85. So this is giving us new probabilities to work with, and so now I have a new expectation. So I can say, I guess I'll say the expectation of x, I don't know how to write this, actually. I guess I'll say y. So given x equals 0 is not possible, the expectation of x is now, well, 1 times its associated probability. So I'm going to write 0.21 over 0.85 plus 2 times its probability plus 3 times its probability. All right, and so there we go. Let's calculate that. So we have the 0.21 divided by 0.85 plus 2 times 0.4 divided by 0.85 plus 3 times 0.24 divided by 0.85. And so there we go, we get 2.0353. So the expectation is greater than. Now, again, if you want to be really nifty, you can just argue that since this 15% needs to be accounted for in the remaining options, they all will increase. And so let's just see that in the scoring guideline. So good news is I got everything else correct right off the bat. They chose to solve part A just the straightforward way, adding up 1, 2, and 3. And then the expected value, got that right as well. And then part C, got that right as well. Now notice they used x equals 3 instead of all, so that's probably the better way to go. But then, so for part D, they just give a verbal answer. Given at least one ATM is working, the expected number would be greater since by eliminating the possibility of 0 working ATMs, the probabilities for 1, 2, and 3 working ATMs all increase proportionally. So in other words, I guess you can see that technically before all of these were over 1, each of these little individual 0.21s, 0.4, and 0.24s, and now, since the answer choice is eliminated, they're all out of 0.85. So in other words, you're making the denominator smaller, so you're making this whole fraction proportionally larger. So they're all growing by that same proportion, being divided by that 0.85 instead of being divided by 1. But you don't actually have to even write that out mathematically, so let's see here. So also, you can see my probability could be calculated like this. Now they also just be careful about how you write that down. They need to make sure that's written in the correct way. Also, part B, again, just compute it and show the work. So again, be careful that you show that work. Don't just type it into the calculator. As I've said many times, if you're going to do anything in the calculator, write it on the page. Right? Again, numerator and denominator. So don't simplify that. Make sure you show the numerator and the denominator numerically before you simplify if you're going to. So again, part E, you can read through all the responses, but this is how I saw it. It just didn't think of me to word it like that. I just calculated this by hand after checking it, and then realized this was a way that you could go. But again, technically it's that each of these values, back at the question, each of these values, the probabilities are technically over 1, and you're now eliminating this, and now you're putting everything over 0.85, which is actually making everything larger. So, wacky question. Everything was very nice and easy until part D. But there you go.